All right, here we go. Here we go. Section 2.1, the derivative and tangent line problem. So calculus, this is a little history for you, because I know you're interested in that. Okay? Calculus grew out of 4 major problems that European mathematicians were working on in the 17th century. Long time ago, 1600s. 1. The tangent line problem. Okay, and that was in 1.1. You can clean 1.1 and 2.1. Okay, 1.1 we already did that. Okay, we already did that, and then we're also going to do it in 2.1. And 2 is velocity and acceleration. Okay, and that's going to be 2.2 and 2.3. And then 3 is minimum and max problems, which is chapter 3. And 4 is the area problem, which is 1.1 and chapter 4. That was the rectangles, okay? We did the long way with the rectangles. We're going to learn a short way to do that in chapter 4, okay? So, this is calculus. This is what it comes from, really. 4 major problems, and we're going to touch on all 4 in this course. Come hell or high water, okay? So, there's a graph, I can go over. There's a graph on page 91, okay, and it has 3 different tangent lines. I don't have it in front of me. So I'll get to it, page 91. Okay, oh yeah, here we go. So, one of them is if you had a curve like this, where the line is horizontal, okay? The line is horizontal. Another one is if your curve's doing this, okay, and your line is negative. And the other one would be if your curve does this, and your line is positive. Okay, so you could look on page 91 and get better pictures of that, but that's what we have, okay? 3 different tangent lines. Continuing with 2.1, the word derivative is going to be slope. We got to get used to that. Get used to hearing the word derivative and know that it means slope. And when we think of slope of a line, we're talking y2 minus y1 over x2 minus x1, right? We call that delta y over delta x. Delta means change. It means change in y over change in x. And then we could also write it this way, ready? F of c plus delta x minus f of x over delta x, okay? So where does this come from? Well, let's say we had a graph. Okay, we've got a graph. The graph looks like this. This point here is c, f of c. And then this point here is going to be c plus delta x, comma, f of c plus delta x. Okay? So what does that mean? What does terminology mean? Well, we're here at this point, and then we're adding something to c to get from here to here to our x. And then when we plug that in, we're plugging it into our y. So if we think of it, right? If we think of it and we found the slope of this, we would take this minus this, f of c plus delta x minus f of x, this and this, okay? Actually f of c, right? And then on the bottom, you would have c plus delta x minus c, and the c's cancel, and that's what we get, okay? So, this is huge for you. Huge, 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 okay? Remind me to do this in class. Review the binomial theorem. If I haven't already done that, make sure that I do. I don't know if I want to do that on a video. I don't know if I want to, because I need to have you practicing and we need to be talking about it, okay? So remind me, I need to do that. But this is huge. This formula is huge, okay? The limit as delta x goes to 0 of f of x plus delta x minus f of x all over delta x. This is the definition of a derivative, okay? Definition of a derivative, okay? Know that a vertical line has no slope and the derivative of a vertical line doesn't exist, okay? But this is huge. We're going to find derivatives using that formula. When you go to college, some of your professors are going to make you do it out like this for every derivative that you do. In my mind, it's a monumental waste of time. However, who am I to tell some college professor how they want to do it? So we're going to learn how to do it this way. And then after this, in section 2.2, I'm going to show you a shortcut, which you're going to like a whole lot more. But I've got to show you both ways. I don't know what's going to happen. I don't know where you're going to go. I don't know what they're going to do. All right? So let's look at a problem. Ready? That is the definition of a derivative. It's like the limit, using the limits to find derivatives. Okay? So let's say that I had y equals x squared, and I wanted to find the derivative. Okay? Well, I have to follow this formula. So this formula says that I plug in, well, I write down the limit as delta x goes to 0. Limit as delta x goes to 0. I've got to plug x plus delta x into my function. My function says x squared. So I'm going to have x plus delta x squared. Then it says minus f of x. Well, what's f of x? Y is f of x, right? I could have written it this way. Minus x squared over delta x. So now we got to do the math. Do the mathematics. So I'm going to multiply this out. You should be getting good at this by now. X plus delta x times x plus delta x. X times x is x squared. X times delta x is x delta x. X times delta x is x delta x. Delta x times delta x is delta x squared. Minus x squared all over delta x. So now we cancel what we can. Let's take a look. This cancels and this cancels. And on the top, I can factor out a delta x. So if I factor out that delta x, I'm left with, whoa, well, wait a minute. Let's combine our like terms first. x plus delta x. I'm going to take one more step here, okay? And combine those like terms. The limit as delta x goes to 0. X delta x plus x delta x is going to be, whoops, 2x delta x plus delta x squared all over delta x. In my numerator, I have delta x. I can factor that out. I'm left with 2x plus delta x. Now, these delta x's cancel. Now I can plug in my delta x, plug in my 0 for delta x, because I don't have a denominator anymore. And that's going to wipe out that term. So the whole thing is equal to 2x. Okay? That is your first derivative. Now, for notation, if they say f of x, I would write it this way. I would write f prime of x. That's the notation. And they want to see notation. You're big boys and girls. You can do notation. If it's y, you could write yours as y prime, or you could write it as dy dx. Let me go through that. Let me go through some notation before we try another problem. Okay? So, if the function is written as f of x, and right up here, big thing, notation, then the notation for the derivative, okay? If they give me f of x, the notation for the derivative is f prime of x. If they give me y, I could write dy dx, that stands for derivative. You're differentiating y with respect to x, or you could write it as y prime. If they gave me s, then I could write ds dx, comma, s prime. Let's see if there's any others down here. Okay, I think that's it. We'll get into some notation more as we go. Okay? But let's look at another example. Okay, let's look at another example. Let's do an easy example. Okay? Let's do an easy one. I'm going to rewrite this up top here so you guys can see it when we do these. Okay, we have the limit as delta x goes to 0, f of x plus delta x minus f of x over delta x. We're going to do an easy one. We do lots of practice with this stuff, lots of practice. So let's say that f of x is equal to 3x plus 2. An easy one, a linear equation. Okay? So when we're finding the derivative, if it's f of x, the notation for the derivative is going to be f primed of x. So I'm going to write f primed of x is equal to the limit as delta x goes to 0. Now let's go back to our formula. The formula says I take my function, whatever that is, and instead of x, I replace it with x plus delta x. So I take this, and I replace that with x plus delta x. So I'm going to have 3 times x plus delta x plus 2. And then I've got minus f of x. Well, that's this. So I do minus 3x plus 2, and that's all over delta x. So it's still my derivative. It's still the limit as delta x goes to 0. Let's do a little algebra. This is going to be 3x. This is going to be 3 delta x plus 2 minus 3x minus 2. So 3x minus 3x cancels. 2 minus 2 cancels. I'm left with 3 delta x over delta x. Now I still can't plug it in, so it would still give me a 0 for my denominator. However, these cancel. So my answer to this is just going to be 3. You're going to say, well, where do I plug in the 0? There's no variable. It's a constant term. Your answer is 3. Okay? And easy. Let's look at one that's a little bit more complicated. A little bit more algebra. I erased the formula. We know it now. We know the formula. So f of x equals 2x squared plus x minus 1. 2x squared plus x minus 1. Well, here we go. Ready? F prime of x. And if you think you can do this, I bet a lot of you can already. I bet a lot of you can do this already. Pause. Pause the video, try it, see what you get. That's how you learn. That's how you learn. I can't be there to hold your hand. Okay? The limit as delta x goes to 0. Now, I'm going to write it out again so you guys can see it. See what I'm talking about. F of x plus delta x minus f of x all over delta x. So I have to take x plus delta x and plug it into my function. So wherever I see an x here, I've got to replace it with x plus delta x. So I have 2 times x plus delta x squared plus x plus delta x minus 1. Okay? Minus whatever f of x is. Here's your f of x. 2x squared plus x minus 1. And that's all over delta x. The limit as delta x goes to 0. Now we've got to do some algebra. Now, one thing you want to be careful of. Follow your order of operations. Okay? I can't multiply by 2 first. I have to square this first. So I have x plus delta x times x plus delta x is going to give me x squared plus x delta x plus x delta x plus delta x squared. I got to take that, multiply that by 2. So this, in parentheses, is going to be x squared plus 2x delta x plus delta x squared. And then I multiply that by 2, so I'm going to get 2x squared plus 4x delta x plus 2 delta x squared plus x plus delta x plus x plus delta x minus 1. Okay? And then minus 2x squared minus x plus 1. And that's all over delta x. So let's cancel what I can. Okay? The 2x squareds cancel. The x minus x cancels. This minus 1 and that plus 1 cancels. So what am I left with? I'm left with 4x delta x plus 2 delta x squared plus delta x. So now I want to factor out a delta x. So if I factor out a delta x, I'm going to have 4x plus 2 delta x plus 1. The limit as delta x goes to 0. I have that delta x there. 4x plus 2 delta x plus 1 all over delta x. So what happens with the delta x's, the delta x's cancel. Now I can plug in that 0. It wipes that term out. So the answer to this is 4x plus 1. That's my derivative. Okay? Good stuff, man. Good stuff. If you don't like doing that stuff, you shouldn't be in here. I'm going to be honest with you. All right? If you don't like that, if that's not your thing, then you might not be in the right spot. Okay? You might not be in the right spot. But you'll get better. It's the way these things work. Okay? The way these